Welcome friends. This is the answers explaining session for task 2 questions. Before entering into task 2 questions, I will explain the answer for today's question. This is our first and interesting question because we are in the topic fluid mechanics. This is one of the interesting question. The question is a fluid is on which can be defined as the substance that there are four options. We have to select the perfect one answer. First option is has the same shear stress at all points. Is it true? Just visualize it. Has that same shear stress at all points. It is wrong statement. The reason behind it is that we know that when we apply a shear stress on the surface of the fluid, especially water or gas, the shear stress at the force applied layer and the below layer will be different from the below layers. It means that at lowest layer there will be no shear stress. At topmost layer there will be a maximum shear stress. Therefore, this point is not valid. Then we can go into the second option. Can deform indefinitely under the action of smallest shear force. Just visualize it too. This is possible because when we apply a shear stress on the fluid surface, it will deform indefinitely. That is the main word. Indefinitely is the correct and suitable word. Therefore, this option is possible. Option C has the small shear stress in all direction. Fluid itself doesn't have a shear stress. When we apply a shear stress on it, then only it has a shear stress. Okay, therefore this option is away from our question. Practically incompressible. How this is possible? Incompressible includes, here the question is not liquids, fluid. Therefore fluids are classified into compressible and incompressible. Therefore this option is also not valid. Therefore the correct option for this question is option B. Can deform indefinitely under the action of smallest shear force. That's it. Now we can discuss the answer for task 2 questions. This is the first question of task 2, which is from general aptitude section. Two pipes P and Q. This is one of the very interesting question. Okay, you just visualize it. There are two pipes P and Q can fill a tank in 6 hours and 9 hours respectively. Respectively indicates that P fills 6 hours and Q fills the tank at 9 hours. While the third pipe R can empty the tank. Look at this word, empty the tank in 12 hours. Okay. Initially P and Q are open for 4 hours. The P is closed and Q is opened. Opened. After 6 hours, R is also closed. The total time taken to fill the tank in hours is dash. We have to find the total time taken to fill the tank. This is one of the interesting question and simple question. We no need to make a big calculations at all. Just we can calculate the answer for this question in a simple way. I have solved in a different sheet. You can see the sheet. I will show you. Okay, now you can look at the screen. You can see the solved answer sheet. This is invisible if you have minimum brightness, so please increase your brightness first of all, then it will be look clear for you. Okay, I wrote that first step is peak and fill a tank in 6 hours. Then simple logic, how many hours it will take to fill the half of the tank? Just divide by 2. Therefore it takes 3 hours to fill a half of the tank. Similarly, for at 1 hour it can fill, for 1 hour it can fill how much? Find out that. Remaining 50 percentage, that is remaining 50 percentage, divide by 3 equally, then we will get at 1 hour 16.66 percentage. Similarly do for Q, that is to fill half of the tank it will take 4.5 hours. To fill it, fill how much for 1 hour? In order to find this, divide 50 divided by, yeah, 50 represent another 50 percentage we have to fill now. That's what here I taken 50 divided by 4.5. I will get the answer as 11.11 percentage. And for R, this P and Q it's for filling and R for emptying. Similar same logic here too. To empty half of the tank it will take 6 hours, because totally take 12 hours, half of the tank 6 hours. Using the same logic as the above, for 1 hour it will take 50 by 6, we will get as 8.33 percentage. Initially P and R are open for 4 hours. Okay, P is open for 4 hours. Then calculate, we know that 1 hour how much we can fill. Say multiply the into it with 4, we can get for 4 hours how much it can fill. Similarly, how can R can empty for 1 hour, we know, multiply by 4, it get 33.32 percentage. Therefore net filled, because one is filling, one is emptying, therefore net tank filled now is that subtraction, that is difference between this P and R. Then we had found out that 33.3 percentage till now it is filled. Then after the second condition, that is second statement, is that P is closed and Q is opened. Okay, Q is opened now, and after 6 hours R is closed. Then it means that both Q and R are opened for 6 hours simultaneously, and after 6 hours R is closed and Q is just continuing. Okay, therefore Q can fill, we know that 1 hour it will 11.11 percentage. Therefore for 6 hours it will take, multiply by 6, it will give 66.66 percentage. Similarly for R it will take 49.98 percentage. Here the net filled in the tank is nothing but the difference between Q and R is 16.66 percentage. The net initially there are filled in the tank is 33.3 percentage. Just add with this net, then finally the net filled, net liquid filled in the tank will be 50 percentage. Then remaining 50 percentage I have to filled by Q alone. Till now it taken 10 hours. Okay, that is for initially 4, then 6, totally 10 hours. From now Q how take how many hours, we have to find that. Remaining 50 percentage, therefore 1 hour we know that 11.11 percentage, multiply by 4 we can get that 44.44 percentage, and remaining 4.55 means remaining on half an hour it will be taken. Okay, therefore just add it with 10 hours, we will get the net hours to fill the tank is 14.50 hours. That's it. The option containing this value is, let me see. So we can see the option containing that value is option B. Therefore correct answer for this question is option B. This is the second question, which is from our topic fluid mechanics. Okay, this type of question already we have seen in task 1 itself. Just apply your knowledge here. Newton's law of viscosity states that shear stress on a fluid is directly proportional to what? We know that already, I have explained this in task 1 itself, that shear stress of a fluid is directly proportional to shear strain, which is du by dy. Therefore here du is the change in velocity and dy means change in height. Therefore the correct option for this, that is the option should contain velocity as well as the height. Therefore the correct option for this question is, correct answer for this question is option C. Okay, velocity alone never come, and in second option there is no regarding any height, and third option too there is no regarding height. Only option containing change in velocity and change in height is option C. Therefore correct answer for this question is option C. That's it today. Subscribe my channel and click the bell icon to receive questions daily. Thank you.